All right, we are going to look at our second day of review for Chapter 9. We are focusing on the calculator methods in this lesson. Our first question says to use RREF, that is reduced row echelon form, to solve the system or show that no solution exists. To do that, we want to set up an augmented matrix. So we start with our coefficients, 3, -4, 4, and our constants go on the end. We have 1, -1, -2, and 2. And for our third equation, we have 2, -3, 6, and 5. All right, so we're going to enter that in our calculator. We need to go to our matrix screen, so second in our inverse key. We want to go over and edit a matrix, and this one is a 3 by 4. All right, and our numbers are 3, -4, 4, and 7 for our first row. Second row, 1, -1, -2, and 2. And then our third row, 2, -3, 6, and 5. All right, now we want to quit out of that and then go back into our matrix screen. This time we want to go over to Math, and we need to scroll down to find RREF, Reduced Row Echelon Form. I'm going to hit Enter, then I need to go back into my matrix and tell it which matrix to use. I put that in matrix A, and I hit Enter. All right, so my RREF solution gives me this: 1, 0, -12, 1, 0, 1, -10, -1, 0, 0, 0, 0. All right, so then we look at that last row. It's going to tell me that I have an infinite number of solutions. All right, since the whole bottom row is a 0, or they're all 0 entries, we have an infinite number of solutions. So this would be my x's, my y's, my z's, and my constants. Z can be anything. That's what this row is telling me. And then the second row says that 1y minus 10 z's equals -1. And if I solve that for y, I'd have to add the 10z over. And the top row is telling me that 1x minus 12z's equals 1. So again, solving for x, I'm going to add the 12z to the other side. And so I end up with expressions for x and y, and then we know that z can be anything. So my solution would be 12z plus 1, 10z minus 1 for y, and z is any number. Okay. Our next example, same situation, we're using reduced row echelon form. So I'm going to create my augmented matrix. My first row coefficients are 1, -2, and -1, and my constant is -5. Second row I have coefficients of 2, -3, -1, constant 0. And bottom row 3, -4, -1, and 1. Okay, so I'm going to enter that. So we're going to go back into our matrix. We're going to edit again. It's still a 3 by 4. Our numbers are 1, -2, -1, and -5. 2, -3, -1, and 0. And bottom row 3, -4, -1, and 1. All right, quit out of that again. Now, the last command that I gave my calculator was to do a reduced row echelon on matrix A, and since I replaced this same matrix with my new matrix A, I can just hit enter again and it will recalculate it with the new one. All right, so we do our RREF and we end up with this. Okay, and again we start by looking at the bottom piece, this bottom row. It is telling me I have 0 x's, 0 y's, and 0 z's, but they're supposed to add up to 1. This is a case where we get no solution. That is not possible. All right. Question 16. It says, find, if possible, A times B and B times A given these two matrices. Okay? Now, we could do this by hand, but this is in our calculator portion of the test. So we are going to enter these two on our calculator. All right, so let's go under our matrix again. We're going to edit. Our matrix now is a 3 by 3. All right, the first matrix has 2, -3, and 2 for a first row. Second row, 5, -5, and 2. And the third row is 4, 1, and -1. Okay, that is matrix A. I'm going to quit out of that, go back into my matrix screen. This time, though, I'm going to edit matrix B. I'm going to make a 3 by 3 again. This time I have 2, 4, 3 for my first row. Second row, 4, 1, 5. And third row, 2, -3, and 2. All right. Now, it says, find if possible. Remember the rule for multiplying matrices. We look at the size. This one has 3 rows, and it has 3 columns. Okay? Same thing here. It's a 3 by 3. And the rule for multiplying, if the middles match, we can do the multiplication, and the size of our answer will be these outer dimensions. Okay, so let's go back and let our calculator do A times B. All right, so we're going to go back into our matrix screen. We are going to name matrix 1, and then we're going to go back into our matrix screen and matrix 2. So we have A times B, and we hit enter. So my solution for A times B should be -4, -1, -5, -6, 9, -6, and 10, 20, and 15. Okay? Now, they've also asked us to do B times A. So, back to our calculator. Our matrix, this time we want B first, and then matrix A. Enter. We'll multiply them, and we get 36, -23, and 9, 33, -12, and 5, and -3, 11, -4. Okay? So matrix multiplication on the calculator. All right, question 17. It says, write the linear system as a matrix equation in the form AX equals B. On your test, I would expect to see you identify all 3 of those matrices. Okay, so matrix A will be your coefficient matrix. So we take just the coefficients. So this is a little smaller than our augmented matrix. We just have our coefficients in there. Then we have our variable matrix. Our variables go in the order X, Y, Z. We create a column matrix for that. And we are saying that if we multiply these two together, we should end up with our constants, 2, -2, -10. Okay? So notice that I have marked what I've called each matrix. Then it says, for part B, solve the system using the inverse for the coefficient matrix. So if I want to find these variables, my variable matrix, I need to take the inverse of matrix A and multiply it to matrix B. I do expect to see that notation on your test. Okay, so you're going to identify what the matrix is. So you're going to give me these matrices. You're going to give me this equation here. And then you're also going to give me this. Once you've done that, you can go to the calculator to finish it up. All right, so we have to enter some matrices. All right, let's get rid of that. Okay, second matrix. We're going to edit. Matrix A, we want to be a 3 by 3 matrix again. My first row is -4, 3, 3. My second row is -4, 1, 3. And my third row is -4, 1, 1. Okay, so matrix A is set. Quit out of that. Go back into your matrix screen. This time we're going to edit our second matrix. We are going to make matrix B be a 3 by 1. So just a column matrix. We need numbers 2, -2, and -10. Okay, so we've got the two matrices stored in there. Now we want to do the inverse of A. So I'm going to go back into matrix and name it. Okay, I want A. Then I need to hit my inverse key. Then I go back into matrix and pick B. So I have the inverse of A times B, and I end up with 4, 2, 4. So I would say matrix X is 4, 2, 4. The solution to this system of equations would be the order triple 4, 2, 4. All right, and our last question for today's review. It says to use Cramer's rule to solve the system. Cramer's rule is where we use determinants. So we are going to set up our first matrix. We want the determinant of it. So remember, those straight brackets mean determinant. My first matrix is just my coefficients. So 1, 1, 1, 6, -1, 1, -1, 5, -1. Okay? I'm going to calculate the determinant of that. Then I need to set up three matrices, one for X. When I set up the X matrix, I am basically going to replace the X coordinates, so this first column from my D matrix. I am not replacing the second and third columns, so I'm going to go ahead and put those down. But in place of my X coordinates, I'm going to use my constants. So in this case, I need 0, -5, and -30. Okay? Then I'm going to set up a matrix for Y. Same idea. I need a determinant. This time my first column doesn't change, and my third column, my Z's, don't change. What changes would be my X's. So now I put my constants 0, -5, and -30 in for my X's. And then the last one that I have to set up is for Z. My first column and my second column do not change. My third column now is replaced, my Z values, with my constants. All right, so we are going to have to now go into our calculator and let it find the determinant of each of those matrices. All right, so go back into our matrix screen. We're going to edit the first matrix, and that one is a 3 by 3. Our numbers are 1, 1, 1, 6, -1, 1, and -1, 5, -1. Okay? Quit out of that. Now I want to find its determinant. So second matrix, go over to the math menu. It's the very first option. The determinant of matrix A, hit enter, and I get an answer of 30. Okay, so the determinant for my initial D matrix is 30. Now I'm going to do that same thing for the other three matrices. So let's go back. We're going to edit this matrix. It's still a 3 by 3. My numbers are 0, 1, 1, -5, negative 1, 1. And bottom row, negative 30, 5, negative 1. Okay, quit out of that. My last command was to find the determinant of matrix A, so I can hit enter again. And this time I am getting a value for matrix D sub x of negative 90. Okay. Go back into our matrix screen. We're going to change our matrix again. This time we want 1, 0, 1, 6, negative 5, 1, and negative 1, negative 30, negative 1. Okay, quit out of it. Again, I can just hit enter. It's already calculating determinants. This time I get a determinant of negative 150. All right, and I've got one more to do. All right, edit. We still have a 3 by 3. This time we want 1, 1, 0. Second row 6, negative 1, negative 5. And third row, negative 1, 5, negative 30. Find the determinant of that one, and we end up with 240. All right, so what we do with those now, to find our x coordinate, we are taking D sub x, the determinant of our x matrix, divided by the determinant of our initial matrix. So we are taking this negative 90 and dividing by the 30 that we had. So our x coordinate would be negative 3. Our y coordinate will be D sub y divided by D. D sub y was negative 150 divided by our 30, and we get negative 5. And our z coordinate, we want D sub z divided by D. We had 240 divided by 30, so we get 8. So the solution to this system would be negative 3, negative 5, 8. All right, so for your review, this is the calculator part. Page 931, you are going to do questions 5, 8 through 11, 41 to 44, 48 and 49, and 54 and 55. You are allowed to use your calculator, but again, what I've shown you in our notes today should help you see what kinds of work you would need to show on your test.